Aniket, can you hear me? Let's start our discussion now, everyone.
Yes, sir.
Okay. So in switching concept, we are trying to focus on our next topic is called STP, Spanning Tree Protocol. Spanning Tree Protocol. Why this concept is required in switching scenario? Why we need this concept, STP? So let's discuss a scenario. For example, I have a switch device. Okay, I have a switch device. Switch one, for example. Multiple computers are connected with this switch. Multiple computers are connected. Now, in my scenario, in my building, I have one more switch. I have one more switch. For example, this is switch number two. This is switch number one, and multiple computers are connected with this switch. Multiple computers are connected. Now I have switch number three. And yes, multiple computers we have here, this side. Now, in case if I want to connect these switches with each other, Aniket, Fabian, if I want to connect these switches with each other, so yes, we can connect like this, right? Everyone, we can connect like this. For example, this is fast Ethernet 0/1. I'm connecting with 0/1. This 0/2. I'm connecting with 0/2. So I can connect cable and these interfaces I'm using as a trunk, right? Remember our trunk discussion? in between switch in between switch, we are using trunk interface because trunk consists VLAN databases. Okay, so we have a simple topology. All the computers, they are communicating with each other. For example, okay, this inside machine, for example, this PC number one, trying to communicate with machine this machine, for example. Now this traffic will go and hit on the switch, and if there is no entry for this destination MAC address, if you guys remember our switching concept, switch will take forwarding decision based on MAC table. And if entry is not available in MAC table, so switch will do broadcast, right? Switch will do broadcast on all interfaces. So for example, MAC address entry is not available in MAC table, this destination MAC entry. So now switch will receive this signal. It will send broadcast packet on each interfaces, and on this trunk interface also. This this broadcast will go and hit on switch number two. Now it's a new traffic. When switch will receive this broadcast, it will send out on all interfaces, right? And when this machine, my point is, when this machine will give a reply packet, so now this switch has a information about this MAC address in MAC table. Aniket, Fabian, remember this basic discussion?
Yes, sir.
Yes, sir.
When communication happen, switch will generate MAC address information in MAC table. That's great, no problem. Simple discussion. Now, here into this topology, I have redundancy. Okay, I have one more cable in between switches. See, I am using one more cable. This cable I'm using for backup. For backup, if this interface goes down, so no problem. You can go from switch 3 to switch 2, switch 2 to switch 1. You can communicate like this if this interface goes down. So my point is, we have a connectivity like this. Now into this scenario, again this inside machine. Okay, let's talk about new traffic. This inside machine, my point is, this inside machine is trying to communicate with the machine IP. This traffic will go and hit on switch. Switch don't have entry about this information in MAC table, so it will do broadcast. It will send broadcast on all interfaces on this interface also, on this interface also, When this switch will receive broadcast, it will send broadcast on all interfaces and on this interface also, on this trunk interface. Now, what about this? Broadcast is going to hit on this switch 30/2 interface. When this switch number 3 will receive broadcast, it will send this broadcast on all interfaces, including this trunk interface. So broadcast is going to hit here, and this side we have a broadcast. So this broadcast will create loop in your network. This broadcast will create loop in your network. Clear my point? This is called
Yes, sir.
broadcast strong. This is called broadcast loop. Fabian,
Yes, sir. Yes, sir.
so what is the solution? What is the solution into the scenario? The solution is I can disconnect this cable. My point is I can disconnect this cable. No problem. So there is no any loop. Broadcast will hit on this interface. It will go and go to switch number 3, which will send broadcast on these interfaces. Broadcast will hit on switch number 2. So it's not creating loop. But if you have a redundant cable in between switch number 2 and switch number 3, a backup cable you can say. So it's this is what this will create loop. You have a redundancy, but this will create loop. This will create loop. This will create broadcast loop. Now let's discuss one more scenario. Let's discuss one more scenario. I have a switch number one, switch number two, switch number two. Multiple computers are connected. Multiple computers are connected here. So I'm trying to connect both the switches. So yes, I can go with a cable, right? I can connect like this. This is, for example, fast Ethernet 0/1, 0/1, 0/1. Yes, I can connect a cable. Now, in case if this cable if this cable is not working, for example, maybe some issue. I don't know what is the issue. Maybe some issue. This port is not working in a real network. So what you can do, if this cable is not working, this port is not working. So this LAN computers, this you can say this side you have client machine, this side you have server machine. So they cannot communicate with each other. They cannot communicate with each other. So what you can do, you can connect one more cable. This cable you are using for backup. If you are adding one more cable, if you are adding one more cable, this is the first one, this is second one. This is what first one, this is second one. If you are adding one more cable for backup, then this traffic, this machine, for example, trying to communicate with this destination computer, for example, when switch will receive this broadcast, it will send out on all interfaces. This broadcast will hit on this interface. It will go and hit on switch number 2. This broadcast will hit on this interface also. So this will create loop. This will create loop. So what you can do, you can connect your backup cable. My point is, you can connect your backup cable, this backup cable, but manually I'm using shutdown command. Shutdown. So I'm using shutdown command on this interface. For example, 0/2, 0/2. Aniket Fabian. So this interface is down. I have a cable, but this interface is down. I'm only utilizing this interface for communication. So this will not create loop because this interface is down. When broadcast will hit on these interfaces, broadcast will hit on switch number 2, it will send on all interfaces, but this interface is down. So this will not create a broadcast loop. Great, no problem. But now in case, if this interface goes down, maybe some issue. So in a real network, what you can do, if this interface goes down, a real network, what you can do, you can first try to identify what is the issue. Client machine, they cannot communicate with the servers. What is the problem? If there is any IP address mistake, okay. So after some time, you can identify this 0/1 port is not working. So what you can do, you can access switch number 1 or switch number 2 through console, and you can use no shutdown command for 0/2. So you can utilize this interface. Your communication is happen via this interface. This interface is not working, so your communication is happen via this interface. Aniket, clear my point, Fabian?
Yes, sir.
But
Yes,
this is
sir.
but this is manual task, everyone. This is what? Manual task. If this interface goes down, then you can access both the switches through console. You can go into your interface. You can type no shutdown command, then you can utilize. It's a manual task. So as a network engineer, I'm looking for some automation. Okay, I'm looking for some automatic option. Automatic option. What is automatic option means? I have multiple multiple redundant cable. Okay, for example, I have one interface in between switch number one, switch number two, one more cable, one more cable, one more cable. So I have multiple backup cable, multiple backup port. Okay, for redundancy. So one interface, my point is one interface I want to use as a up interface, forward interface, and rest of the interfaces I want to use as a down. And in case if this interface if this interface goes down, then automatically any interface in between these three interfaces, any interface will act as a active automatically. I'm looking for this automatic task. Okay, I don't want to go with manual concept. Manually, you can go to interface, you can use shutdown, no shutdown command. No, I have multiple backup. Like one interface goes down, other will take the responsibility. Second will goes down, next will take the responsibility automatically. So I have four redundant cable, four interfaces in between switch number one, switch number two. But I'm only utilizing one interface. The rest of the interfaces are in block state. Block state. And if this forward interface goes down, maybe some issue. So automatically any interface will act as a forward. If you are working in a Cisco scenario, don't worry about it. In Cisco, there is a concept is called STP, spanning tree protocol. It's an open standard protocol. So this concept you can use on any vendor. Any vendor. STP will provide you loop-free network with redundancy. Loop-free network with redundancy. And the good thing is what? STP is by default enabled on Cisco switches. So don't worry about it. Okay, you can just connect your cable, multiple cable. Automatically one interface will go in forwarding state, and rest of the interfaces they are in blocking state. And if any interface goes down, rest of the interfaces in between rest of the interface, any interface will act as a active. So we have four interfaces. One interface is in forward state or active state, and rest interfaces are in blocking state. If this interface goes down, automatically any interface will act as a forwarding, and your communication is happening via this interface. Okay, you can do this task because of STP, spanning tree protocol. Clear now? STP will provide you redundancy with loop-free network. Aniket, clear my point? Fabian,
Yes, sir.
Yes, sir.
if you are working with Cisco switches, for example, I have switch number one. Okay, switch number one. This one is switch number two. This one is switch number three. Okay, so I have connectivity like this. Yes, I have a redundant cable in between switches. So this is 0/1, 0/1, 0/2, 0/2. Okay, 0/3, 0/4, sorry, 0/3. So now we are working with Cisco switches. So STP is by default enabled. STP, spanning tree protocol, it's by default enabled. Okay, so if you want to know about STP scenario, STP concept, so you need to know some points in STP, some point. So the first point is what? Root bridge concept. In STP, you need to know root bridge concept. So in STP scenario, we are working with 3 switches. So one switch will act as a root bridge. In STP scenario, for example, if you are working with 50 switches, 50 switches. So one switch will act as a root. One switch will act as a root bridge, and rest 49 switches are called non-root bridge. So I'm talking about background process, how STP will detect one interface as a forwarding interface and rest of the interfaces are in blocking state. How STP work. Okay, so I have 3 switches. Into the scenario, one switch will elect as a root bridge. I have 3 switches. So one switch will act as a root bridge. If I'm working with 50 switches, 100 switches, one switch will act as a root bridge and rest 49 switches or 99 switches will act as a non-root bridge. So how they will elect one switch as a root bridge? So there is a condition. There is a condition. Condition is what? Priority value. STP priority value. STP priority value. A switch is having least priority value will act as a root bridge. Will act as a root bridge. A switch is having least priority value. Default priority value for any Cisco switch, STP priority is 32768. This is default priority value. For all Cisco switches, this is default STP priority 32768. Let's take example on switch number 1. I have a priority value 0001. Just example, okay? Just example 0001. Here we have a priority value 0002. Here we have priority value 003. So on switch number 1, we have least priority value. So this switch will elect as a root bridge. The switch will elect as a root bridge. This is the first condition, Aniket, Fabian. But in case, if there is a tie, in between priority value, then if there is a tie in between priority value, for example, here we have default priority value 32768. Here we have 32768, 32768. So if I have priority value, same priority value on all switches, so you can see there is a tie. There is a tie. And the tiebreaker is what? Tiebreaker is least switch MAC address. A switch is having least MAC address will elect as a root bridge, and MAC address is fixed. MAC address is fixed for all switches. So switch is having least MAC address. Least switch MAC address. For example, here we have just example, okay? 0005. Here we have 0006. Here we have 0007. Just example, okay? It's not a MAC address format. So on switch number 1, yes, we have least MAC address. So this will elect as a root bridge. Aniket, clear? Fabian?
Yes, sir.
Fabian for you?
Yes, sir. Yes, sir.
So now let's take example. This switch, everyone. This switch number 1. This switch number one is acting as a root bridge. For example, maybe this switch is having least priority value or least MAC address. Okay, any condition. My point is this switch is acting as a root bridge. You can verify. Let's verify this information first. So I have a simple topology. Let's go with some switches. You can connect your cable. Before connect cable, let's verify some information on CISCO switches. Let's verify some information. So I'm using this command show spanning tree. We are getting a message. No spanning tree instance exists right now. Okay, we are getting this message. Let's give a name, host name. For example, this is switch number one. This is switch number one. This one is switch number two. Switch number two. Now this one is switch number three. Switch number three. Let's connect a cable now. Okay, let's connect a cable. Let's connect a cable. Okay, and wait. So into this scenario, one switch will elect as a root bridge automatically. Okay, and default STP priority for any Cisco switches 32768. So we are using default priority value. Let's start our verification here. So you can just connect your cable and you can start your verification. You can use a command show spanning tree. Show spanning tree. You are getting a message. This bridge is the root. This switch number one. The switch number one is a root bridge. Let's verify on switch number two. Let's verify on switch number two. Show a spanning tree. This switch is not bridge. You can verify on switch number three here. So a spanning tree, this switch is not a root bridge. But if you verify, you are getting a message. This bridge is the root. Why this switch is a root bridge? Aniket, Fabian. Here we have default priority value. As I said, default priority value is 32768. Okay, we have VLAN number one by default. So it's add in your priorities. That's why you can see 32769. Why? Because it's add VLAN number. So priority value is showing 32769. So why this switch number one is a root bridge? Let's verify. Because we have same priority value. There is a tie. Tiebreaker is a switch is having least MAC address will elect as a root bridge. So you can verify your MAC address information. The switch MAC address, show version command. This is switch number one, MAC address. Let's copy this. So switch number one. Now let's go to here. Show version. Switch two. Now let's go to switch number three. Switch number three. Now, so we have MAC address information 00, it's match, 00, it's match, 00, it's match, 11. I think it's not copy. Let me check. This is switch number three. Okay. I need to right click and copy. This is switch number three. Give me 2 minutes. Let's go to switch number two. Right click and copy. Now you can verify. Now you can verify. You can compare 0, 0, 0, 0, 0, DE. So MAC address format is what? It is in a hexadecimal format, right? So this 0, here we have 0, here we have D, here we have E. So here we have least MAC address, right? Aniket, Fabian.
Yes, sir.
That's why this switch is acting as a root bridge. I hope it's clear, this theoretical concept.
Yes, sir. It's
That's why
clear.
this switch number 1 is acting as a root bridge because we have least MAC address. Okay, least MAC address. Let's go to switch number 1. Show a spanning tree. Yes, this bridge is the root. Now you can verify, you can see into this small topology, automatically, Aniket, Fabian, automatically one interface, you can see this 0/2 interface. This 0/2 interface automatically it is in a forwarding state. It is in a for automatically, right, Aniket, Fabian? We just connect a cable, right?
Yes, sir.
Automatically one interface status is what? Forwarding, right? And this interface status is automatically, this interface status is what? Automatically blocking state. Automatically, because STP is running. STP is by default enabled on CISCO switch. So STP will provide you redundancy with loop-free network. So in case if this interface goes down, automatically this interface will up. This interface will go in forwarding state. Let's verify. Let's verify first. 0/2. This interface is down, for example. Maybe some issue. This interface is down. Now you can verify. You can type show a spanning tree. So this interface, you can see this interface is down. Automatically, this interface will go in forwarding state. Automatically. You can type a command, show a spanning tree. See, right now status is learning. So we'll discuss port status, listening, learning, forwarding, we'll discuss later. But you can verify automatically it is in a forwarding state, right? Fabian, automatically, right? So you have a communication via this side. In case if this interface will come up again, 0/2, no shutdown, this interface will become it will become forwarding again. See, automatically this interface, it is in a blocking state again. And this port number 2, it is in a listening state. So listening will take 15 seconds. Learning will take 15 seconds. In STP scenario, each interface, each port will do listening and learning. Listening will take 15 seconds and learning will take, see, LRN. This is learning. This is LSN. So any interface cannot immediately in forwarding state. No. Each interface in STP scenario, each interface will do listening and learning. 15 seconds for listening, 15 seconds for learning. And after 30 seconds, this interface status what? Forwarding. So my point is now why this interface, everyone? This interface is a forwarding port and automatically this interface is in a blocking state. Why? Fabian, Aniket, clear my point?
Yes, sir.
How they automatically decide, how switch automatically decide this 0/2 interface is in a forwarding state and this interface should be blocked. Why? How they will decide? Let's talk about background process. So now, if you are here, okay, we are trying to verify from here. This is your root bridge. As per your task, this is what? Root bridge. So if I'm trying to go from this switch to root bridge, I have two route. I have two path. I can go via this side, right? I can go via this side or I can go via this side. I have two paths. If I'm going via this side, if I'm going via this side, So here we have STP cost. Every interface has STP cost, and we are working with fast Ethernet interface. So fast Ethernet interface STP cost is 19 by default. 19. If you are working with gigabit Ethernet interface, gigabit Ethernet, then STP cost is 4 for gigabit Ethernet. It's a default. If right now we are working with fast Ethernet interface, so these interfaces STP cost is what? 19. So if I'm going via this side, I'm using fast Ethernet. So cost is what? 19. And if I'm going via this side, I'm going via this side. So 19 and what? 19. So via this side, total cost is 38. And via this side, total cost is what? 19. So via this side, my point is via this side, we have least STP path cost. We have least STP path cost. That's why this interface automatically, it is in a forwarding state automatically. Automatically in forwarding state. And this interface is in a blocking state automatically. That's why. Okay. So this is our first option. This is our first option. I'm talking about what? Wait. Okay, let's change something. Wait, let's change something, okay, into this topology. So I'm trying to delete this cable, and via this side, I'm trying to use gigabit Ethernet interface. So gigabit Ethernet, gigabit Ethernet 0/2, for example. So this is gigabit Ethernet, everyone. This switch is a root bridge always. Why? Because we have least MAC address. So this is gigabit Ethernet STP path cost is 4. So this side we have 4, and here we are using fast Ethernet interface. So STP path cost is 19 to reach this root bridge. So you can verify again. See, now you can verify slow spanning tree. Now you can see 0/2 interface is in a blocking state. And via this side, STP path cost is 19. And gigabit Ethernet 0/2, this side, STP path cost is 4. 4. This side is what? 4. So via this side, 4 and 4, what? Total 8 STP path cost. And via this side, STP path cost is what? 19. So via this side, my point is via this side, we have least STP path cost. That's why this interface is in forwarding state, and this interface, it is in a blocking state. I hope it's clear, Aniket. It's not complicated, everyone. Fabian,
It's clear. It's clear.
Aniket,
Yes, sir. Clear.
clear now? Now, let's discuss one more scenario, everyone. Let's discuss one more scenario. So the first condition is what? A path is having least, a route is having least STP path will elect as a forwarding state. Now let's discuss one more scenario. Okay, I have a different topology this time. Topology is different. Topology design is different. So I have connectivity like this. So into this scenario, one switch will elect as a root bridge, right? Let's check. Let's verify. Okay, let's verify any switch. For example, this switch shows spanning tree, so this switch is not a root bridge. Okay, let's verify this switch. So spanning tree, yes, this switch is a bridge. Okay, so this switch is a bridge. Wait. Okay, so this switch is a root bridge. For example, it's a switch number 4. Switch number 4 is a root bridge. Show spanning tree command. You can use, see, this bridge is the root. Now you can verify on this switch. One interface is in a blocking state and another interface, it is in a forwarding state. You can verify, show spanning tree. See, automatically, this interface, this 0/1, it is in a forwarding state. This 0/1, it is in forwarding state, and this 0/2, it is in a blocking state automatically. Why this 0/1 is in a forwarding state and 0/2 is in a blocking state? Let's talk about background process. So into this scenario, everyone, this switch is a root bridge. Yes or no? Aniket, Fabian, this switch is a root bridge. You're right, everyone.
Yes, sir.
This switch is a root bridge. Now, so from this switch, if I'm trying to go to root bridge, I have two paths. I can go via this side, I can go via this side. And I'm using fast Ethernet interface. So STP path cost is 19, 19, 19, and 19. So via this side, we have same cost, 38. Via this side, 38. So via both side, we have same STP path cost. So there is a tie. Into this topology, there is a tie. There is a tie for STP path cost. Then tiebreaker. Tiebreaker is what? A switch is having. Switch is having least MAC address. MAC address will elect as a forwarding port. You can see now. Let's check this switch MAC address. This switch MAC address. Okay. Show version command. So this switch MAC address is what? 00D0. Let's check this switch MAC address. This switch MAC address. Show version. So here we have 00E0 and here we have 00D0. So you can see now on this switch. On this switch, we have least MAC address. That's why via this side, this interface is what? This interface is in a forwarding state and this interface automatically in a blocking state. So if there is a tie in STP path cost, tiebreaker is a switch is having least MAC address will elect as a forwarding state. Aniket, clear? Fabian? Clear, everyone?
Yes, sir.
Let's discuss one more scenario. Let's discuss one more design for STP, one more design. So I'm connecting cable, one more cable. You can connect one more cable, no problem. Multiple uh, redundant interface I have in between switch number 1 and switch number 2. So let's check. One switch will elect as a root bridge. Wait, let's take time. Okay, so this switch is a root bridge. Why? Because all interfaces are in forwarding state. Yes, this is root bridge. Root bridge, all interfaces are in forwarding status. Okay, let's go to this interface, this switch number 2, for example, into this design. So you can verify, everyone. You can verify show spanning tree command. Automatically, this 0/1 is in a forwarding state, and rest both interfaces are in blocking state. Both interfaces are in blocking state. Why? Why? Now let's talk about this design. Okay. Into this design, okay, this is root bridge. This one is what? Root bridge. So if I'm traveling from this switch to root bridge, okay, if I'm going via this interface, yes, we have fast Ethernet interface. So STP path cost is 19. So 19 via this side, 19 via this side, and we have one more interface, 19. So via all three interfaces, we have same STP path cost. So there is a tie, right? There is a tie. Then tiebreaker is what? Least switch MAC address. So you can see now, if I'm going via this interface, I have a same switch. If I'm going via this interface, I have a same switch. If I'm going via this interface, I have a same switch. So now this time, there is a tie. This time, there is a tie of MAC address. So if there is a tie in between MAC address, then tiebreaker is least port number. You can see on this switch, we have three interfaces, port number 2, port number 3, port number 1. So least port number will elect as a forwarding port, and rest interfaces are in blocking state. Clear my point? Aniket,
Yes, sir.
Fabian? Okay, let's continue this topic tomorrow, everyone. Okay, it's not finished. Let's discuss STP tomorrow. Okay. Bye, everyone. Take care, guys. Good night, everyone.
Okay, sir.
Bye.
Bye, sir. Thank
Bye.
you, sir.